Um, Welcome to the talk about IPv6. It's, well, also as we're on ContainerDays, it's a bit of with a focus on cloud and containers, obviously. Still, for, yeah. For the beginning, first quick part, I'm Alexander. I'm a DevOps engineer at Cloudical. Besides that, I'm working on Rook.io, which is, storage in Kubernetes. I'm a certified Kubernetes administrator, and, well, yeah. Quick shout out to Stefan Fideus. He pointed me to the Kubernetes Kind project, which just got a new release, where I'm especially, which I especially like is the IPv6 support, or especially the first IPv6 CI for Kubernetes, as I tried it out in especially like dual stack machines. We'll get into that in a second. And it was kind of a pain. There we go, a full tweet. It's just good to see that it's finally getting more and more acceptance, if you will, so from Kubernetes side, and that it will hopefully soon, without too many issues, work not only with IPv6 but in a IPv4 and IPv6 model. So thanks, Stefan, for pointing it out. So IPv4 versus IPv6. Problem with IPv4, kind of simple to put. There are no more IPv4 addresses, at least none that's, well, obviously I forgot the name, not the Danik, not the RIPE, thank you, the RIPE was it. There aren't really any more IPs to buy officially. Like, you can probably get them basically underhand from like some companies selling them, but normally you don't really get any more. Problem kind of with that at least is the pain I have. In Germany, I think especially, there's like a lot of customers from with their internet connection are sharing one IPv4. Already kind of going a bit further with that, if you have thousands of users behind one IP, and let's say one guy does something dumb and logs in for the 100th time with the wrong credentials, would you block the IP? If you would block thousands of users. Well, with IPv6, depending on how you see it, might not get better, but still. I think it's getting a bit more excessive with IPv6, but we're getting into that. With IPv4, yeah, well, at least right now, as said, multiple users are sharing one IP. So if you block an IP, or even like fraud detection kind of based on the IPs, if you will, so as it's in the end still one data point that you have there for such fraud detection, is kind of getting more and more tricky to do. The second point on my slide, the not enough IPv4 bandwidth available, is more or less kind of a hint at the ISPs, which are kind of like, yeah, you have your 400 megabits internet connection, and you try it download something over IPv4 and get like 5 megabits, and then you download something over IPv6, and you get like 40, the actual 400 megabits. So some ISPs are kind of using this a bit to put wool over our eyes. So, well, at least for the second point, kind of as a hint for people that have the same problem, if you use a VPN to just tunnel everything over IPv6 to like I use WireGuard mostly, you most of the time get like actual 40, you get more speed in the end. For IPv6, in comparison to IPv4, it doesn't solve all the problems. It's just as it is. We're talking about how old this is now? 10, 15 years or so? So it's, it just couldn't solve all the problems. But it's still fine, it's good, because we have at least a good amount of improvements. Especially thinking about containers, you don't have NAT anymore with IPv6. You have every server most of the time as a /64, and, well, they can directly connect to the container, basically, if you will so. Which, There are a few issues kind of or around like DNS or something with some delays in Kubernetes, for example. I think especially because of I think source node or destination node, some weird issues. Well, I personally see this as a total win, not a problem. It's pretty cool to have everything reachable and just the amount of addresses, to not restrict. I want to like, yeah, I need another address. Oh, other network guys giving me another IPv4 address. No, I don't think so. Okay, now we need to rethink the project or something. So, yeah. With kind of the fraud detection point, a huge problem is that the /64 block is around like, let me just skip ahead. There we go. Is well, I'm not going to try to read out the numbers, but well, you're going to have a bad time scanning that. So going back here, a big point which IPv6 brings into the game against like IPv4, it allows for automatic configuration, that you just kind of like normally would start with one server, configure the IPv6 on there, and then from that point, it could basically all go automatically. That all servers would automatically already like the link local address, which are just for the local network, are able to figure that out without having any duplicates. Who has ever dealt with duplicate IPv4 addresses or any kind of IP addresses duplicates? Well, it's fun to find out. It's well, such things are pretty cool about IPv6. For DNS part, well, there's multiple ways you could configure DNS for IPv6 servers. Still, in the end, you have at least some way to have this automated. And as I kind of like to say, instead of just having a service discovery, why not have a server discovery, where each server is starting up, getting this IPv6 automatically configured with the help of the other servers running, and it will just send a signal to the discovery and say, hey, I'm this and this host name, these are my IP addresses, and let's go, kind of like. The cool thing about IPv4 and IPv6 especially there is that IPv4 perfectly fits into IPv6. Meaning that, for example, to have the 8.8.8 point, I think I'm already one dot too much, but you can just put it in, and this would equal this address basically. And you could do it hardcore way if you want to really have it like hex way, but it's simply possible. So there is normally not too much change between IPv4 and IPv6 if you look just at like what addresses are in the logs in the end. They are just longer. Well, kind of more or less why IPv6? Hey, if you're so many IPs, what do we have to worry about? I think we can run a few containers in that. So, well, I'm booked. And for IPv6, obviously, with many addresses, we have auto configuration in some extent. For the client side, we have the so-called privacy extensions. One quick word to them about them. It's basically like where you can shuffle, because you simply have so many addresses, you can kind of shuffle the last few parts of the IPv6 address you're using to communicate with other servers, or well, with the internet. And well, that's making it kind of privacy, if you will, so. Stateless auto configuration, well, as it like that, servers are automatically configuring like the IPv6 address and so on the servers. It's possible with IPv6. Well, Dad to the rescue. There's also, at least to some extent, exactly this duplicate address detection in IPv6, so you don't have duplicate IP addresses running in this in a whole cluster, for example. It just brings some other interesting cool things that I kind of see as getting the network to be a bit more autonomous if you let it be autonomous. Well, kind of 2 or 3 stories with IPv6 with kind of failures. If you enable IPv6 in your network, be sure to have the firewall also set up to block or at least, yeah, well, block IPv6 traffic if you don't want it to go through to the servers. Because, well, IP tables and IPv6 tables is something of a difference, so be sure to have IPv6 firewall rules in place. Point for applications, more or less, if you save IP addresses. well, check the database for the performance side, especially, because you just have so much more to store. And well, if you store IP addresses as a string, well, let's not talk about it. But you should hopefully store it in RAM as like actual bytes with multiple columns to have the optimal performance in the end. But it's more as like, hey, make sure that the application is able to handle that. For IPv6, one big part is also that the ICMP-v6 protocol is heavily used to, for example, even discover MTU and so on, like other factors of how can I talk in a perfect way with the other machine and so on. So if you block it, you're gonna have a bad time. It's just as it is. One problem that I hear from some people, at least, is like, yeah, IPv6 has such long addresses. Well, let's talk about localhost here. You could write it as this, obviously. I think this is a bit shorter, but, well, I'm no expert. The same for other addresses in IPv6. It's just, most of the time, looks long, but, well, you could probably just cut it down to be shorter in the end. Yeah, well, exactly kind of my reaction to IPv6 addresses are too long. Another solution to this is, well, simply using DNS. What does speak against using DNS for, well, everything? If the DNS servers are a problem in your infrastructure, you have something to fix. Because it's this is no argument, guys. It's a vital part of the infrastructure. And if it's broken, it's broken. You have to fix it. God damn it. Well, if for whatever reason you can't use DNS, there's still use some automation, service discovery / service query as I called, and just automate the configuration generation all the time when the IPs change for whatever reason. Well, and again, kind of with the IPv6 having so many addresses, I just had to do it to you guys. Well, before everybody is going like, yeah, IPv6, let's go, keep in mind, at least for some companies, I hope I'm not talking to anyone directly with that. Some companies already struggle with just being able to manage IPv4 for their servers and so on. Or as I like to call, hey, network guys, can I have an IP for this server? Sure, please create a ticket. And a week later, my server has an IP. What? For the people that remember it, IPX and SPX, who remembers it? Well, if you're still using it, well, have fun, I guess. But yeah, well, you should consider probably looking into IP protocol itself then, unless you have a very, very good reason. If, for example, the network guys at your company have like using an Excel sheet for network management, IPAM, use IPAM, something like from DigitalOcean, Netbox or something to manage the IP addresses, because it's just getting a mess if you have an Excel sheet. Like, well, quick checklist. I think I'm able to upload the slides on the schedule later on. It's kind of just like it's kind of like a checklist for, hey, you need to sell it to the CIO, CFO, see the actual cost in the end, again, complexity, and how you can deal with legacy systems that can't just go IPv6. And well, also clean up the inventory afterwards. One last point, change your mindset with IPv6, because you have so many IP addresses. You can address your server, your network equipment, the Internet of Things, so your toaster and stuff like that. But you can also go ahead and give every atom in a tomato, and I think even the Earth or something like that, huge amount of number. That's basically with the many stars. Yeah? Well, you have so many addresses. Well, it's perfect for containers. That's it. Yeah.